Okay, let's give you guys some more practice. So find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, you can't simply divide everything by the highest. You can't simply do this. Divide 6 to the power of n, divide 6 to the power of n, divide 6 to the power of n. This one here will head towards 0. This one here will head towards 0. This one here heads towards 0. This here heads towards 1. So here you've got 0 over 1, which is okay. So here you've got 0 to the power of 1 over n. But then you can't. You see, when you get to 0 to the power of 1 over n, you can't make use of this. You can't make use of this. You can't make use of a constant to the power of 1 over n, because this constant here needs to be strictly be greater than 0. Here you've got 0, it equals 0. Here you've got equals 0 to the power of 1 over n. If you can get this to be, let's say 0.273 whatever to the power of 1 over n, then yes, you can say the limit. Then you can say the limit is equal to 1, because here it's here x is here it requires x to be bigger than 0. Here you've got here x is bigger than 0, so it's okay here. But then when you try and do 0, to the power of 1 over n, you see, if you divide everything by the highest, 6 to the power of n, 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 this whole thing here will be 0. 0 to the power of 1 over n is meaningless. So you can't simply just divide everything by 6 to the power of n. So here's a trick. So to do this, so we know we can't divide everything by 6 to the power of n, 6 to the power of n. So let's factorize this. Factorize out the 4 to the power of n. So looking at this, do this. Hang on. 2 to the power of n over 4 to the power of n plus 1. You see, rewrite this as this, because if you get this, multiply with this, multiply with this, it will give you this. So this is just a trick. So rewrite this as this, and then do the same for down here, but factorize out the 6 to the power of n. So it's like this, 6 to the power of n. So if you get this times this and this times this, it will give you this thing here. Okay, so basically rewrite this as this, and then rewrite this as this. So this remains the same. So now break this up into 2 fractions. So here you've got 1 fraction, which is this one here, and then this whole thing here is another fraction. And then rewrite this as this. So now you've got 1 block multiplying another block. So remember a, b to the power of c. This times this times this. So now you've got 1 over n times n. So that will be to the power of 1. And then this whole block here, you can imagine this whole block here as being to the power of 1. So this thing times the 1 would be the same thing, but just to the power of n. Well, basically do this. From here, this times this will give you this, and then this times, imagine the whole thing here to the power of 1. So 1 over n times 1, that's 1 over n. So from here, that will then take us to here. And then this here is a constant. This here is a constant. We can take it out here, and then now we can make use of this, because now x is actually x is actually greater than 0, because look at this here. Hang on. So here, oops, sorry. So here, let's look at this bit here. As n tends to infinity, this thing here is less than 1. 2 over 4 is a number less than 1. If you get a number smaller than 1 and you keep on multiplying by itself, it's going to get smaller and smaller and smaller and smaller. As n tends to infinity, this is going to head towards 0. This is going to head towards 0. So you've got 1 over 1, which is 1. So now this whole thing here is the number of 1. So 1 to the power of 1 over n. You see, now we can make use of this now. Now we can make use of this. Our Rx here is 1. Rx here is 1. Now 1 is bigger than 0. So we can make use of this now. Before, right from the start of the video, we couldn't, because x was 0. X was 0 to the power of 1 over n. We couldn't do that. But here, because x is greater than 0, we can make use of this now. So this being 1, then the whole thing here, making use of this, will head towards 1. So this whole block here is actually 1. So now 1 times this thing will give you this thing. So the limit is really 4 over 6. Okay. So next one here. So find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so let's just say y is this thing that we're trying to find. So natural log both sides. So this thing here will come down here. That will then give you this. You've got your natural log here, 1 over n, 1 over n here. So now you've got one fraction multiplying another block here. This thing here gets multiplied to the top, giving you this. So now this thing is this, and then rewrite this as n to the power minus 1. So whenever you natural log one thing to the power of another thing, this thing here can come down here. So that will then give you minus 1 times this thing here, and then minus 1 is a constant. So you can take it out to the limit. So that gives you this. And then now exactly the same divided by exactly the same. This thing here is going to head towards 1. This whole thing here is heading towards 1. You've got a negative here, so it's negative 1. So negative 1. So now that we're here, exponentiate both sides. So e this side, that will then give you this. These two cancel out, giving you y, and then this. Well, the limit is e to the power minus 1. Okay.